Every place you're about to see began with a real photograph taken on Mars by NASA. But we won't just be looking at photographs, we'll bring these places to life and move through them, as if we were flying over them ourselves, like the Mars helicopter Ingenuity. So if NASA's rovers mostly sent back photographs, not video, where did this footage come from? We brought real NASA images of Mars to life with a neural network. One trained on vast amounts of real footage, millions of frames showing how cameras move through real landscapes, how light shifts, and how motion follows real-world physics. A quick example. On the left, real video, a drone flying over a rocky landscape here on Earth. On the right, almost the same kind of motion across the terrain, but built by a neural network from a single frame. This is how we'll bring real images of Mars to life today. Nothing drawn from scratch. Not a desert on Earth dressed up to look like Mars. A real photograph taken by rover, put into motion. February 2014. On the road to Mount Sharp, Curiosity ran into a problem the team could no longer ignore. Along the way, sharp Martian rocks had punched holes and cracks into its aluminum wheels in several places. It needed a gentle route. The alternative to the rocky ground lay through Dingo Gap, a narrow sandy passage blocked by a dune about a meter high. For a human, that's almost nothing. But for Curiosity, a machine weighing nearly 900 kilograms, it was a new test. The rover had never crossed a dune like this before. One wrong move and its wheels could spin, dig into the sand, and leave Curiosity trapped there for good. The team spent almost 2 weeks sizing up that crossing. And then, success. Here is its trail. 2 tracks pressed into the Martian sand. Curiosity captured this scene twice in a single day. Once at dawn, and once late in the afternoon. NASA's engineers merged the 2 frames into one and tinted them. Blue for the morning, orange for the evening. But Curiosity's navigation cameras record the world in black and white, and this is how they captured the view. To the right, rises the slope of Mount Sharp, a 5-kilometer mountain Curiosity has been climbing for years. And ahead, beyond the sandy plain, tens of kilometers away on the horizon, stands the far wall of Gale Crater, the crater Curiosity has been crossing since it landed. Namib Dune is a part of the dark Bagnall sandfield on the flank of Mount Sharp. Curiosity rolled right up to it, digging a wheel into the sand and scooping samples for analysis. This was the first time scientists could study active sand dunes up close, not on Earth, but on another world. And these dunes aren't frozen in place. They move roughly a meter every Earth year. The sand is creeping even now, slowly reshaping the slope. Mars isn't stuck in its past. It's still changing today. For more journeys into the questions that still remain, subscribe to the Before We Arrive channel. The same wind that moves the sand can do something else too. Look at these dark hills. It's no accident they resemble one another. Each one has the same hard cap on top. These aren't dunes, these aren't mountains. They're buttes, what's left behind. There was once a solid layer of rock here. For millennia, the wind wore away the softer material around it. But a tough, dark layer lay on top, and beneath it, the rock survived. That's how these hills came to be. Everything loose was stripped away, and only what was shielded remained. The team named the hill on the right Bolivar, and Curiosity was driving between these hills for a reason. This was a threshold. Beyond them began a region scientists had waited 10 years to reach. Layers of salt. Salt is left behind where water once evaporated, and this pass was carrying the rover out of an age of water into the age when Mars dried out. Sometimes the hardest thing on Mars is simply driving. This narrow corridor between the hills is called Paritopui Pass. On the left, the hill Deepdale. On the right, our old friend Bolivar. Curiosity worked its way between them for more than a month. Beneath its wheels, sand ridges and broken-up rock. And the sand stopped the rover more than once. More than once as Curiosity neared the crest of another ridge. Its wheels began to slip. Engineers had built Curiosity as a safeguard for exactly this. When the slipping grew too great, the drive would stop automatically, so the wheels wouldn't dig in. Then, from Earth, the team would send Curiosity a command to back up. They would study the terrain again and look for another route, where the sand was shallower. Meter by meter, attempt after attempt. The hills got in the way too. Curiosity sends large volumes of data through orbiters passing overhead. But when the slopes of the pass blocked the sky, those communication windows became harder to use. But ahead, beyond these hills, a place awaited Curiosity where water once rippled. Curiosity is standing in Marker Band Valley. It's named for a thin dark band of rock that scientists first spotted from orbit. Right beneath the rover, stone covered in ripples. Waves made them. Real waves in shallow lake, lapping here billions of years ago. In all its years driving through hundreds of meters of lake deposits, Curiosity had never found clearer traces of water than these. And here's the puzzle. This area formed at a time when Mars was already drying out. So, where did the waves come from? The rover tried twice to drill into this rock, but never managed it. The stone was simply too hard, and the central mystery remained unsolved. Where did the waves come from on a planet that was already losing its water? Now we move to another corner of Mars, Gusev Crater, where the rover's Spirit once explored. Before you is a plain scattered with dark stones. They look ordinary, but they may hold the trace of a catastrophe. Billions of years ago, an explosion tore this place apart. Dark, porous, almost foam-like. Only one force makes rock like that: fire. The leading theory among scientists is volcanic activity. Molten magma breaking through to the surface and hurling this material outward. But there is a second idea. The rising magma may have met not empty ground, but underground water or ice. The water flashed into steam, and the sudden pressure blew this place apart. Fire and water on ancient Mars. If that's how it happened, then here, beneath Spirit's wheels, lies the memory of their collision. Jezero Crater, the rover Perseverance. The site was chosen from hundreds of others for one central reason. If life ever existed on Mars, this is one of the places where its traces are worth looking for. Billions of years ago, a lake filled this crater with a river flowing into it and building a delta. River deltas, better than almost any other landscape, can bury and preserve the faintest traces of the past. So, Perseverance drills this unremarkable ground and seals samples of ancient rock inside titanium tubes. But the central question cannot be answered here, on Mars. To know whether these rocks hold signs of life, they have to be brought to Earth, to laboratories. A backup set of those tubes lies on the surface of Mars. The rest remains sealed inside Perseverance. All of them are waiting for a way home. September 2025. Curiosity arrives at something it had never seen before: boxwork formations. A web of stone rising through the Martian surface. Their story began with water. Billions of years ago, water seeped into a crack in the rock and left dissolved minerals behind. The minerals hardened. Then over ages the wind wore away the softer rock around them and exposed the hardened frame. What we are looking at isn't a riverbed or a shore. It's the trace of water hidden inside the rock. The water itself is long gone, but the stone still holds the lines it once flowed through. Getty's Valles. At its center, a heap of boulders and debris. An ancient flood may have carried them here. Water that once raced through this place billions of years ago. But what makes this spot remarkable is something else. Those rocks may have come from above, from higher layers of Mount Sharp, from layers curiosity will most likely never reach. The rover won't climb to every page of this mountain, but some of those pages already lie below, in the rocks, in the rubble, in the trail of an ancient flood. NASA's rovers piece its story together layer by layer, valley by valley, stone by stone. Somewhere higher up there are still layers no whale has ever touched. Not yet. But perhaps one day another robot will reach them, before we arrive.